Hello, SAT students. Mrs. Scott here, ready to go through lesson number 11 with you for our SAT prep. This topic is talking about systems of equations, mostly linear. I think we threw one nonlinear in there, but linear systems of equations. This is going to take us back to Algebra 1 for a lot of these problems, okay? So let's go ahead and start with a little warm-up here of solving a system by substitution method. Okay, so to get the substitution method all set up, we need to isolate one of the variables in one of the equations. So I'm choosing the y in the top equation just because it's a simple variable to isolate. So if I subtract this 7 over to the left side, that's going to give me a y equals 2x minus 7. So if I can take this 2x minus 7, I can now take that and plug it into the y because that 2x minus 7 is equivalent to y. So I can plug it into the other equation and that'll eliminate one of the variables for me. So let's try it. We get a 5x equals a 2 parentheses 2x minus 7 plus 15. Distributing this 2, I get a 5x on the left still equals a 4x minus 14. Drop down that plus 15. All right, I'm going to do a couple things in the next step here. I'm going to subtract this 4x over to the left. 5 minus 4 gives me 1x. And then I'm also going to combine on the right the negative 14 and the 15, which obviously combines to 1. So there's my first variable that I've solved for. X is 1. And now that I know that, I can take my x and I can plug it back into any of the equations. It's always easiest with substitution to plug it into that equation where we isolated a variable. So I am going to plug in 2 times 1 minus 7. 2 times 1 is 2, minus 7 is negative 5. That's my y value. And of course, with a system of equations, we always write our answer as an ordered pair. So this ordered pair, it goes x comma y, 1 comma negative 5. Okay, so for your notes, you might want to write down x comma y. There's the answer. Now, you may notice that in the next problem, it's the exact same problem, but this time it says solve by elimination. So I want to show you that we're going to get the same solution whether we use the substitution method or the elimination method, and it's going to be up to you on which one's easier. With elimination, we want to rearrange everything so that we're kind of lining up the x's and the y's and then the constants. So I'm going to go like this. With this first equation up here, I'm going to rewrite it as a 2x minus y equals 7. I want the equation in what's called standard form, which means the x and the y are on the left side. And underneath that, I have the 5x. I'm moving that y over, so minus 2y equals 15. Elimination means I want to eliminate one of the variables, and I think here it's going to be easiest to eliminate my y's. But right now they don't eliminate, so I need to manipulate that first equation. I'm going to multiply that first equation not just by 2, by negative 2. I'll show you why. We get a negative 4x plus 2y equals negative 14. So I'm distributing that negative 2 to every part of the equation. And that second equation stays the same. And now you're going to see, this is the y. This is the part where I explain why it works. And it's because you'll see now that the y variables cancel out. See ya. Okay? That was the purpose of multiplying through by not just a 2, but a negative 2. In order to cancel, I needed the coefficients to be the same number, opposite sign, and so that did the trick. So now I combine and I get x equals negative 14 and 15 is 1. Kind of saw that coming since it was the same problem as before. And then again, just plug into either equation to solve. I would probably plug into that first equation. 2 times 1 is 2 equals y plus 7. And if I subtract the 7 over, I get negative 5 equals y. And so, once again, my answer is 1, negative 5, x comma y. Beautiful. So you might want to pause this video right now and copy down these pictures. Okay, I actually screenshotted a blank graph to have a graph behind these, but you can just draw them without the graph if you want. Biggest takeaway is that one solution is going to be two lines that intersect one time. A no solution system will be two lines that are parallel. And then an infinitely many solutions will be two lines that are the same line. Okay, two lines that are the same. Also, number 3 says solve by graphing. So I kind of already did some of this for us. To solve by graphing, we need the y's by themselves. And the only weird part is with this second equation, the y-intercept of the line doesn't really come out that nice. So I probably would do this. For the first line, it's an easy graph. It's a y-intercept of -7 and a slope of up 2, right 1, up 2, right 1, up 2, right 1. So I'm just going to draw my line. Now for the second one though, I probably would find the the x-intercept because this y-intercept is a fraction. To find any x-intercept, we plug in 0 for the opposite letter. So I get the 2 times 0 is 0. I'm going to get 5x equals 15. And if I divide the 5 over, I get x equals 3. So I do have an x-intercept at 3. And then this slope is up 5 over 2. So up 5 over 2, maybe down 5, and over 2, and that's that intersection point. So this is actually, with this pen so thick, it's actually kind of hard to see exactly where these intersect, but sure enough, it is going to be at 1, -5, which this is the same problem as the 2 above. So it makes sense that it has the same answer. I am now going to quickly transition into some of these practice problems. I've circled the answer of the first one already, so it's kind of a spoiler alert. But let's talk about the y, okay? This says Anna burned 15 calories per minute running for X minutes and 10 calories per minute for hiking for Y minutes. She spent a total of 60 minutes running and hiking, burned 700 calories. System of equations represents this, so the X value represents minutes, like we said, running. So the question is saying how many minutes X did Anna spend running? It gave me the equations. So really I just want to solve the system specifically for X, okay? So I'm going to do this using, you could use substitution or you can use elimination. It's totally up to you. I might use elimination here. So I would maybe eliminate, since I'm trying to solve for X, I would probably eliminate the Y's and multiply this by -10. So that's going to give me a -10x minus 10y equals -600. And so if I line that up with this original 15x plus 10y equals 700 and add my two equations together, you'll see that the y's eliminate. I get a positive 5x equals 100, so x is 20, and that is the answer. Answer choice B. Okay, moving on. This is a nonlinear system. So I mentioned in the beginning there might be one nonlinear system, and you also want to solve this using elimination. So the idea here is actually, if you look right away, the x's and the y's and the numbers cancel, and I just end up with x squared plus x, which I can't combine those. So if I solve this, I factor out an x, I get two solutions for x, 0 and -1. So this is the SAT, this is a multiple choice question. I'm just gonna pause and eliminate any answers that don't have an x value of 0 and the other x value at -1. Answer choice A, the x values are both -1, so see you later. Answer choice B, both x values -1, bye. Answer choice C, oh, -1 and 0, that one stays. Answer choice D, 1 and 1, oh, see ya. I don't have to do any more of the problem because the only option that works with my x values is C. I'm going to move on, but if you were wondering how to find the y values, I would just take 0, plug it into either one equation. Actually, I highly recommend always plugging back into the linear equation. And then you would also take -1, plug back into the linear equation, and that's how you would find your y values. This next one is a linear inequality. Okay, so in this situation, I would probably graph both of these lines. To save time, I already got isolated y in both equations. So for the purple line, the equation is 2x minus 3. So slope is 2, up to right 1. And that's going to be a solid line. Remember with these, you might have a dashed line. But if you read the question, it's just asking where are the solutions going to be. So that's that shaded region, and it's just asking for quadrants. So if you forgot about a dashed line, it wouldn't kill you on this problem. All right, now for the next equation, this one's a little bit more difficult because once again, I don't get a nice y-intercept. That won't kill you on the problem, but I always think it's easier if the y-intercept's not nice to try to find the x and see if that works out. So if I get rid of the y, then I do get an x-intercept at 4. So again, you just plug in 0 for y. And the slope is 1/3. Up 1, right 3, down 1, left 3. So, all right, now we have to talk about the shading. The purple line is y is less than. So that means I'm going to shade below the line, which is over here. Okay. For the red line, this is y is greater than, so I'm going to shade above the red line. So the question is, which quadrants do these shadings overlap? So if you zoom in here, it looks like it's going to overlap a little bit down here, but definitely up here. So up here is quadrant 1, and then this little section is quadrant 4. So the answer is answer choice A, quadrants 1 and 4. You got to know your quadrants on that one. Not only do you have to know how to graph a line using an x-intercept, you have to know about inequalities, you also need to know about quadrants. Like this is a problem where it's assessing so much from you. All right, so let's move on to number 4. If x comma y is a solution to the system and x is greater than 0, then what is the value of x? Okay, I would do substitution for this one. We know that y is 4x, so I get negative 3x squared plus quantity 4x, quantity squared. So some kids might forget to actually square that 4. We end up with a negative, and that equals 52. Negative 3x squared plus 16x squared, careful there, equals 52. Combining like terms, I get 13x squared equals 52. Divide over the 13, x squared equals 4, and square root both sides, which gives me plus or minus 2. However, the problem states that the x value must be greater than 0, so we just take the positive answer, which is just 2. And this is a grid-in problem, so I would write a 2 and bubble in the number 2 in the ones place. Amazing. Let's move on to number 5. I do go through these quickly so these videos aren't painfully long, but you can always pause, rewind if you need me to explain it again. Number 5, it gives me, this is an interesting one. It says if x equals 3x plus 2 and that x value is greater than 5, okay, then what, which of the following represents the possible values of y? Okay, this is how I would solve this. I would say, okay, x has to be greater than 5, but let's see what happens if x equals 5. If x equals 5, okay, I get y equals 17. 15 plus 2 is 17. I just want to ask myself, are the answers going to be bigger than 17 or smaller than 17? Because 17 is that cutoff point. So I'm going to pick a number bigger than 5 now. Why? Because it says x is greater than 5. So I know that the answers are going to be, the x values will be greater than 5. Not equal to, but the equal to gives me the cutoff point, okay? So the 6, 3 times 6 is 18, plus 2 is 20. So notice that if I pick a number bigger than 5, I get a number bigger than the cutoff number 17. So the answer is answer choice B. Y is going to be bigger than the number 17 if x is greater than 5. Okay, moving on, it says if 12f plus 5g is 15 and 8f plus 15g is 17, then what is the value of f plus g? All right, so this is going to require us to solve the system and then take the two answers, the first one for F, the second one for G, and add those together. Here is how I would do this one. I would solve using elimination. So I'm going to multiply this first equation by -3. Okay, so I end up with negative 36F minus 15G. Now you can see why I chose to multiply it by -3 equals negative 45. And if I add those equations together, my G's cancel. I end up with negative 28F equals negative 28. That comes out nice. F equals 1. Now, if F equals 1, let's find G. I will plug into the first equation. 12 times 1 plus 5G equals 15. 12 times 1 is 12. Subtract it over. I get 5G equals 15 minus 12 is 3. So G is 3/5. I've now solved for F and G, and the question is saying take those answers, add them together. 1 plus 3/5. 1 is 5/5 plus 3/5, just to get a little common denominator, and my answer is 8/5. Answer choice D. All right, let's move on. All right, here we go. We got 2 more, guys. Almost through with this lesson. So starting with number 7, this one is crazy. This is such an SAT problem, it's not even funny, because a student's gonna read this and be like, huh? Here's how I personally would solve this. We got x plus y equals 11. We got y plus z equals 14. And then we got x plus z equals 13. So I was like, all right, what am I going to do here? You can see in blue, I kind of started manipulating some things around. In this equation here, I got the z by itself. And so the z is equal to 13 minus x. I then went back to the first equation, and I got the y by itself. And I got y is equal to 11 minus x. In math, we say that we have equations in terms of x, meaning x is the variable in the equation. So now I have an equation with z in terms of x. In other words, z equals something with an x in it, and y in terms of x. In other words, y equals something with an x in it. And I can use substitution to now solve this. So I'm going to use this equation, but instead of a y, I'm going to put 11 minus x, because that's what y equals. And plus z, which is actually 13 minus x. And then that equals 14. Okie dokie. Now I'm just going to combine like terms. So I get 24 minus 2x equals 14. I'm going to subtract over 24. So I get x equals 5. Now, if x equals 5, I can solve for the other two. 13 minus 5 equals 8, so that's z. And 11 minus 5 is 6, so that's y. And the question is saying add them up. 5 plus 6 plus 8, 19. And make sure you grid in your answer correctly. Okay, there it is. I kind of like that problem, not gonna lie. Okay, I think there's more than one ways to do this. This last one, it says, which of the following is true about the intersection of these lines? You could graph them and see, because look at the answer choices. They intersect where x and y is they're both positive, x and y are negative, x is positive, y is negative. I honestly think I would just solve the system using elimination and then just answer my, multiple choice based off of that. So if I multiply this by 3, I think we'll eliminate the y's. So 12x minus 3y equals 21. So my y's are gone. I get a 13x equals 26. So x is positive 2. Okay, so x is positive. Okay, I can eliminate answer choice B, because the first value is positive. And now I'm going to solve for y. So I'm just going to plug back into this equation here. We get 2 plus 3y equals 5. Subtract the 2, 3y equals 3. So y is also 1. Y is also positive. There is an intersection point because we found a solution, so answer choice D is gone. Both our answers are positive, so the answer choice is A. And that's that, you guys. That's the lesson on linear systems, with the exception of that one problem. And we're good to go. So hopefully this all came back to you from Algebra 1. Some of it's a little bit more Algebra 2, but hopefully you feel good. Always go back and rewind if anything went too fast. Have a good one.